All right. We are kicking off now our Friday, sessions with Marko here. AI for all. Hey there, Marko. How are you doing?
Hi, I'm doing great.
This looks like a very tropical, very nice place you're in. I see Peak Shift represented there. I see the Belgrade Bitcoin Hub. There's a big.
This is Belgrade Bitcoin Hub. They have a beach nearby. They have palms, like everything. It's always a party.
I see. So this was not just set up just now, right? It's always been like that, right?
Yeah,
The room.
most definitely.
well, whoever decorated it is very nice. Except for that bee on the wall there, it's like it needs a frame or something, I think.
Yeah, maybe you're right.
That's
a higher quality print.
Yeah, that's a dig at Pav. Well, Marko, thank you for joining us. Thank you so much for joining us. We have a couple people in the chat there. Sharingan Crypto says hello, and Tony Ide says ole. Ole to you too, and hello to you. We're also going to be joined by Ben Ark. But before we get in, oh, there he is. Benny, thank you so much for joining.
Hello. How's my... As always, I've got terrible signals, so hopefully I'm coming through okay.
No worries. We can hear you loud and clear.
Choppy.
Representing LN Bits.
Oh, good. There we are. Nice. Cool. Nice to meet you, Marko.
Likewise.
Hey. So let's kick it off. Marko,
I think
there's a bit of a delay.
Is there a delay? I think there's a delay.
Yeah, there's a little one. Yeah.
Ah, shit.
Yeah. It looks so tropical where Ben is. I think Marko, he's in competition with you in your tropical room.
Yeah, who has a better beach outside? I don't know.
I'm in Mallorca at a conference in Mallorca, so it's pretty nice.
Oh. Thank you so much for taking the time, Ben. Let's do
Thank
a
you,
round
John,
of introductions.
for organizing.
Thank you so much. Let's do a round of introductions for those who don't know. Marko, let's start with you.
So my name is Marko. I'm originally from Serbia, currently based in Japan, although visiting Belgrade Bitcoin Hub here. I've been working with machine learning and robotics for the past decade, building different systems for different problems, from purely software and machine learning to autonomous vehicles, industrial robots, and the like. That's pretty much it.
Thanks so much. That's 10 years. So like even before ChatGPT, because some people didn't think AI existed before ChatGPT.
Yeah, definitely before ChatGPT.
All right. Ben, you don't need any introduction, but do you mind especially maybe touching on that hardware part and of what you've been doing? Because you've really been the trailblazer in that field, I think, within Bitcoin especially.
Yeah, I think maybe less so these days. I'm pretty tied up with the LN Bit stuff, but yeah, back in the day, there was a lack of a maker community in Bitcoin playing around with cheaper electronics. So they would build nodes on Raspberry Pis, but there wasn't anyone like building, points of sale and DIY hardware wallets and those sorts of things. So me and a couple of others, we encouraged like a maker community. Kind of came out the Lightning Hack days, and then from that we had a software project, LN Bits, which I work on most of the time now, and that made it easier to develop for the hardware and then also software. and it's kind of extendable. You can add extensions onto it, and it's just been a fun journey over the past sort of 5 years. I stopped teaching woodwork 5 years ago, and then started trying to develop stuff, and yeah, it's gone pretty well. And I've been able to take part in the founding of the Nostar stuff, which is super cool. Been around in that for a while too. So yeah, it's a great ecosystem to work in, but obviously, it's people tell me that it's going to be turned upside down and on its head by all the AI. Every time I speak to someone like yourself who's worked in AI for a decent chunk of time, they're a little bit more reserved, or it will take a little bit longer than maybe. I think it's the Turing test thing, isn't it? Suddenly we can talk to the computer and it's freaking us out. But the reality is that
our field is famous for over-promising and under-delivering. We started promising general AI in 1950s, and we're 70 years in and still not there. So whatever we say, take it with a grain of salt.
My big question is when the robots are going to take over, but maybe we find out. Maybe I find out about that towards the end of this.
Let's not spoil it.
Yeah. Okay, so Marco, Ben. So Marco has a presentation ready. He's going to go into some like deep AI concepts, and then the IoT parts are going to be coming in after that, right? And you could jump in at any point in time. But we'll let Marco do some presentation, and we'll take questions, and it should be at least a conversation, right, Marco?
Yeah. So if you have any questions during the presentation, just stop me and ask. I'll be glad to answer. And there won't be any math. So for anybody worried about that, so it's fine.
All right, let's get it up. There we go. Bits and bolts.
AI robots and Bitcoin. Yeah. Let's see how that goes. So the content of the presentation is basically, first I'll try to demystify the whole concept of AI, explain what it is. Then I'll talk a little bit about robotics and IoT and how that fits into the AI field. After robots, we're going to look at software AI agents, basically the thing that you're hearing nowadays all over Twitter and Nostr, right? Everybody's talking about AI agents. We're going to see how to build them, what tools to use, what are the issues. And then the final section will be how we can leverage Bitcoin and Lightning Network for our AI agents. I wanted to have emoji on every line here, but I just didn't have an appropriate one for word agents, so I kind of failed. But yeah, I'll work on that for the next presentation. Anyhow, so in order to even speak about artificial intelligence, we first need to define intelligence. And it's interesting that there is actually no single definition for intelligence. And when you ask different people, they'll give you different answers, right? So basically, is a chimpanzee intelligent, right? Is your PC intelligent? Is an autonomous vehicle intelligent, right? So there's no agreed upon term. So it's kind of hard to actually gauge how far are we on the scale from like dumb computer to superhuman AGI, where AGI stands for artificial general intelligence. But one definition that I like, and it's completely not my definition, I just heard it, right, is that intelligence is agents' ability to achieve goals in a wide range of environment, right? So, for example, if you put a human or a robot or an animal in a city and tell them to navigate the city, go buy groceries in a shop and prepare a dinner, they'll be able to do that even though they've never been in that city, for example, right? Or if you put them in like some rural area and tell them, okay, construct a house here from the material that you have around, again, intelligent agents should be able to do that. They should be able to leverage their cognitive powers, their reasoning, their learning, generalization to achieve tasks in different environments. So, and it's a funny story, but in the early days of AI, we considered chess as like the pinnacle of human intelligence and cognition. And then when we built a system that won over best human player, Kasparov, right? We said right away, okay, that's not AI, that's just dumb system playing chess, right? So we have that pattern that whenever we solve some problem with our computers, with our like AI, we don't call it AI anymore. And right now, there's actually also a big distinction between narrow and general AI, where narrow AI is a system that can solve one problem well, for example, object recognition, right? While general AI is the system that can do object recognition, navigation, imagination, whatever. But okay, let's go to the next slide. Here, basically, we see the kind of different fields and breakdown of the artificial intelligence field. So it's a broad concept, and right now when we think about agents nowadays, we mostly think about systems that are in this small, what is this, yellow or orange circle, right? Those are deep neural networks that consist of like hundreds of layers. But neural networks can be shallow. Machine learning can have different models besides neural networks, and then artificial intelligence has different methods besides machine learning, right? So instead of machine learning, we could use maybe support vector machines, some evolutionary algorithms, and things like that. So yeah, AI is a very broad and umbrella term, and what we usually think about when we say AI nowadays, it's deep learning systems with some bells and whistles. But as we said before, AI has been with us for a while, right? The field started in 1950s approximately, and we have been using one form of artificial intelligence for many different things. For example, time series prediction, like stock market or actually Bitcoin price prediction. You can use AI for that, right? Just predict the price movement of Bitcoin. Then you can use AI to predict your next word in your like iOS or Android keyboard. Predictive keyboard systems, that's basically small AI. But it works slightly different than the current language models, though. Then we also have AI that works with images for object detection, just localizing items in space, both in a sparse way with like on the left side, we call that object detection, and then in a dense way also where the task is to label each pixel with appropriate class. For example, this is very important for autonomous vehicles. When the car is driving on the road, you want to know for each pixel in your camera to what object does it belong, right? So here we see same color for the cars, different color for the road, for the people, for the signs, right? And all those systems are basically AI systems. And then nowadays we have text-to-image systems like Midjourney, like Stable Diffusion and DALL-E, where you put text in and you get image out. Or we have the large language models that can output long strings of text, be it prose or code, like GitHub Copilot, right? And in the same way that there's many AI applications, there's also many AI or rather neural network types. The most simple one is called multi-layer perceptron, and is basically usually very shallow network, and by network it's basically connection of neurons. These nodes are neurons, and the operation that's being performed is matrix multiplication. Basically, you put an input data on the left side and you perform matrix multiplication on that input until you get a final output that says, okay, this is a dog or this is a cat, for example. So that's the first model that we made, and it was loosely inspired by human brain, but not really. As you can see, this does not look like a brain, right? Then these networks work well for maybe, well, they don't work well for almost anything, to be honest. We just use them as auxiliary things for much more powerful networks, but I'll talk about that later. So when we deal with images, we usually use convolutional neural networks, or historically we usually used convolutional neural networks, which is again a network of many layers, but instead of having fully connected layers, you have these 3x3 kernels, right? That kind of move. If this is an image, you have a kernel that goes pixel by pixel across the image and does matrix multiplication, and that is being done like many times in many layers. And at the end, we again get either, I didn't change the slide. So, I'm sorry, I was changing other slides. So this is the convolutional neural network, right? So images at the input side, and then we perform convolutional operation, and then the output side we have the result with a class of the item in the picture, or like a bounding box or a segmentation mask. Then when we deal with the time series, for example, we would usually use recurrent neural networks, and these are three different variations of the kind of same principle. The first one is just vanilla recurrent neural network. And what happens there is that when you have like data that's correlated in time, you input to the network one time increment at a time, right? But then you keep the state in your network from the previous one and combining with the next one. I think I'm doing a poor job at explaining this. But recurrent neural networks are good for when you have to deal with sequential data. However, they're very complicated to train. There is main two issues are exploding and vanishing gradients, but it's not very important. They're slowly, I think, falling out of fashion and being replaced with new and shiny transformers. They were introduced in 2017 in a paper called "Attention is All You Need." And the big innovation in transformers is something called multi-head attention. And basically, that multi-head attention module is module that helps the network attend to different and focus on different input parts. For example, if you feed the whole sentence to the network, that multi-head attention module, this orange block here, can decide which parts of that input are important and how are they correlated. And that is the magic sauce that makes everything run nowadays. And GPT that you definitely know about, GPT-3 and GPT-4, they're based on the transformer network, but it's even simpler architecture than the one on the previous image. It does not have these two separate columns. It only has like a right column, which is called like a decoder only transformer. Not terribly important at this point, but yeah, it's basically the whole large language model movement is based on this transformer network, which is fairly simple, but there is a lot of engineering effort and know-how to actually train it on the scale. And how do we train networks? Just briefly, if we have like, for example, convolutional neural network for images, we have an image of a dog, we put it in the network, and the network has to output, is it a cat or a dog? If it says it's a cat, then we kind of punish network and change these connections in the network. Or if it says that it's a dog, then we say, okay, this is good. Just keep doing that. And we pass millions and billions of examples like that. And at the end, network kind of learns a probability distribution over some data set and becomes useful. This is for the images. For the large language models like GPT, they obviously don't predict images, but they predict next words. So we would input a whole sentence, a paragraph or whatever, and ask it, okay, what is the next word that comes after this? And it outputs something, right? And that's the training loop. And we'll come back to large language models later, but we can look at the robots right now in the same way that there's many types of neural networks for different applications. There's many types of robots, and definition of a robot is also kind of murky. So here on the slide, we have some industrial robots on the left side, basically industrial robotic arms. We have Boston Dynamics dog, which you've probably seen. We also have like a Roomba vacuum cleaner, that is a robot. We have a humanoid robot here in the corner. And then we have cruise autonomous vehicles, which are also robots, and you can drive in them in San Francisco. And I also put an image of a smart CCTV camera. Just an example of Internet of Things device. I wouldn't call it a robot, but it's an IoT device, and it's kind of related. These robots come in different shapes, different sizes, and can cost from like $100 to hundreds of thousands of dollars, right? Depending on the use case and complexity.
That Boston Dynamics robot was scary looking as hell. But also, like the humanoid one that they're doing, they're treating this thing so bad. Like, I think that's what we like. Like, I'm just here to say that, you know, we should maybe be treating the robots a little bit better. You know?
So, well, good thing for us is that right now they're not aware of it, but at some point in the future, if they go on YouTube and check old videos, maybe they'll get angry. I don't know.
Exactly. They're forefathers. Exactly.
Yeah, Boston Dynamics is definitely one of the most advanced robotics companies. They sell Spot commercially, while Atlas, the humanoid robot, is basically R&D platform. It's not something they're selling to businesses. While this robot here on the slide, it's from the company called Agility Robotics, and they're actually selling those robots to logistics centers, and they're able to carry boxes, right, from shelves to trucks and to conveyor belts. They have a bunch of sensors on them. Actually, they have a LiDAR. They have like depth cameras. They're recording QR codes for localization, recognizing humans. So it's very complicated operation. And yeah.
Yeah. So there's a portion of this where you were telling me about where kind of like the Bitcoin payments kind of make sense in like certain areas, but so far like that's not like fully clear for me. Like at what point does that come in?
It's coming in 2 slides.
Oh,
so the slide is just explains how does the typical like advanced robotic stack look like. For example, if you have an autonomous vehicle or a humanoid robot, you would have like a high-level planning module that basically tells the robot what to do, where to go, how to behave. But then you have modules that are for sensing, for perceiving the environment, recognizing humans, making maps of the environment. And then you also have like low-level control, how to actually control the motors of your arms and legs and wheels. And the software stack actually doesn't have to use any of neural networks that we mentioned before. We have traditional robotics methods to solve these things, although they're kind of brittle. So nowadays we are trying to replace them with neural networks. And in the era of large language models, we actually can replace these planning modules and behavior modules with large language models that can kind of reason about plans and decide what to do.
So the
Okay.
transformer model is the thing that's replacing all those other types at this point, is what you're saying? Or is what I'm understanding?
Well, no, that's happening in the research community, right? Nobody yet is putting large language models in production systems because people who use robots in industry are very conservative. You don't want to go cutting edge there because you need a very reliable and well-tested system. Because if a production line stops because of your robot, you lose a lot of money. There's a lot of issues. So when we are building production systems, we tend to favor well-tested and tried methods. But yeah, there's a lot of research in trying to slot large language models for behavior and for planning and for reasoning, and that will happen, right? In a couple of years, robots in industry will be relying on large language models. And now we're yeah.
Sorry, just before you get to the, I would love to hear from Ben, because this is an area in which I think he can contribute some to. So Ben, I know definitely on the sensor side you've been doing a bunch of stuff with these Raspberry Pis and these cheap sensors and stuff like this.
Yeah. So there's clearly when it comes to the world of IoT, there's clearly something powerful about small devices being able to send very small amounts of money to each other. And just being able to stream money between different devices, between different IoT devices. And I think that's I don't want to go cross onto that too much, because I imagine these are probably the slides which are coming up next, which is how AIs, domain-specific AIs, which is what we've been talking about, is how they can purchase resources from each other. How long we have domain-specific AIs before it goes to something more general purpose. I did want to, there's a couple of notes I made actually, because it's really interesting when it comes to, and obviously human intelligence is very hard to define, but there's a wonderful, the anthropologists have a nice way of defining the point in which humans first started thinking. And that's when they first started doing abstract reflection upon their surroundings, and they had to represent it. They had to represent their physical surroundings. They did cave art. That's when, so anthropologists say that's when the humans first started thinking, is the establishment of cave art, which I think is a nice way of imagining in our human intelligence, what maybe separates I'm not saying humans are the only ones who do that in the animal kingdom, but we are the only ones who put pen to paper, put a cave hand on the wall, and draw pictures of gazelles or whatever. Feel the urge to try and communicate this environment in which we're living in. So, wasn't sure if you're aware of that one, but I also like that computers in general. If you talk about Alan Turing, the father of computing, who's he's interested in AI and he's interested in thinking computers. So really the trajectory of computers has always been to create thinking computers, and it's just a matter of time. It's just inevitable for when it will happen. I think the thing I'm most excited about when it comes to robotics is one more thing I wanted to try and get in there, and I think it's actually the most important thing all humans could focus their energy on right now, and that is harvesting robots, like small spider harvesting robots, which can, because if you have harvesting robots, you completely change agriculture. Agriculture currently is a two-dimensional, very bad for the environment, just flat fields with a combine harvester, whereas actually permaculture, you get 4 times the yield per square meter. But it's just, you spend so much time harvesting, it makes it completely inefficient. You can't just drive a combine harvester through it. As soon as we have these little harvesting robots, which can go and pick the mushrooms and the berries and whatever else, and I think it's perfectly plausible they would exist, then we're incentivized to reforest the planet, and we live on the planet of Endor, and we all become Ewoks and live in the trees. So that's something to look forward to. But yeah, I think like everyone else, I got carried away and very excited about being able to talk to the computer. But I do think we're still a long way off from the computer actually, without being told, feeling the urge electively to try and explore their surroundings through the medium of art or whatever.
Yeah.
Ben, have you seen in the there's this community on Telegram called Make a Bit, right? And I was curious, have you been seeing Marco? Could you go back to the previous slide?
Yeah, what in MakerBits we're all developers are using LLM. They're all using ChatGPT, and you're saying, if I want to create something in a microcontroller, I want to get a microcontroller to connect to the internet and create a WebSocket with a website and I don't know, do something. I can ask ChatGPT to do that. It will write the code, and the code will work, which is just crazy, and just does it. And I think it's funny because there's this existentialist crisis which humans are going to have to face up to, where most humans will be made completely redundant in the workplace, and it's not something you're going to be able to stop, because there's no way in which humans were unified to stop the development of AI. So it's definitely going to happen. And I know a lot of developers, and say they've got like a problem they need to work on for 6 months, right? And they're like, well, maybe I'll just do fuck all for 6 months. And in 6 months' time, the AI can probably do it for me in about 30 seconds. So like it's a real like sense of lethargy. But the developers who kind of embraced the AI just sped up their practice. And that's what we do. That's what we do in MakerBits. If you look at Nostar, for example, I was thinking about this because I was looking at the huge rate of development in clients and relays in Nostar, and I swear it's because of the AI. It makes development time so fast.
You never know. It could as well be the AI systems already. But what I was curious about was, like, you're talking about like the generation of the code itself, but what about the control? Like what we're seeing here on this on this diagram, the sensors, and sorry, I don't know how to talk about these topics, but like, are you seeing any projects within the MakerBit community, or have you seen any that actually integrate these AI systems on the robots or on the hardware stuff themselves?
You could. Yeah, there was quite a few years ago, actually, a couple of microcontroller companies. You would buy the microcontrollers, and there was a learning. It had a neural network built into it, so it could do facial recognition and learn faces and things. And that was a very small microcontroller. It's pretty cool. The M5 Stick V, the M5 Stick V, which is RISC-V actually, that got people interested. But it's just pretty fucking hard, like actually developing this stuff yourself on little microcontrollers, and you're really restrained by the limitations of the computers. Also, it maybe just doesn't make sense. Like maybe they should just be secondary devices, and an actual faster computer can be doing the thinking.
Yeah, the issue is that usually these edge devices, especially microcontrollers, they're low-powered devices. They don't have a lot of compute, so you can't even run these large language models. You need to create special networks that are optimized for the hardware, that are quantized, pruned, so very small, very efficient to run on like that weak hardware. So right now we can't run large language models on such embedded devices, but I can run in the cloud and just stream the information.
Gotcha. All right. Well, yeah. Go ahead, then. Go ahead.
Okay. So this is actually the question that you asked me about how to use like those payments. I think that everybody at this point believes that the world will be full of connected devices, be it IoT devices like security cameras, like toasters, small robots for, I don't know, bringing butter, right? Or big robots and autonomous vehicles. And those robots will participate in the economy, and that will. This actually on the left side is a study by MasterCard. So they're basically identifying two problems. One is that their current legacy network will not be able to serve such large amount of devices. And the second problem is that between these devices, the transactions will be small, so their margins, their fees will also be tiny and not actually cover the cost. So they are looking into ways on how they can improve their legacy networks to support this future that's coming. And these agents, they won't be just like hardware devices, they will be also software agents purely in the computer, and we'll look at that later. But right now, for example, when it comes to robots that work in a factory, there is something that we call robotics as a service. So traditional way to buy the factory automation, logistics automation is to do like a capital expenditure. Basically, you allocate $1 million to automate your factory, you buy the robots, you buy the software, you just bring that together, connect everything and make it work, right? But that's like a very long process. You need a lot of money up front, you need a lot of approvals. So the companies came up with the idea, okay, why don't we just copy the software as a service model, right? So robot manufacturers and robot providers would just give robot systems for free basically to the end users, but then they would charge them per month or per year or per day, whatever, right? And even in this right image, for example, if you have a robot that's picking things from the box, you can charge per pick, because, for example, if 1 month you have like low throughput, maybe like your robot is picked only like 10,000 objects in a month, that's not that much. But then next month you have like, I don't know, 200,000 objects, right, that robot handled. Why would you pay the same price for both things? Because in one case, robot is mostly kind of idle, right? So you can charge your customers per pick. So, and in that case, you could use Lightning payments, right? Instead of using the legacy infrastructure with Visa and MasterCard or whatever, you could just have like Lightning wallets and just like transfer sats instantly and with basically no fees.
Yeah, so this seems like it's very much in line with like Amazon warehouses, because like you say like it can pick things, but what are those objects and things that it's picking? It has to kind of like be of interest to the person who is paying that robot to do whatever to execute, right?
Yeah,
Or
so
at least from my understanding. Or are you envisioning like my Roomba in at the Belgrade Bitcoin Hub? It's gonna walk outside and go and clean the neighbor's apartment. I mean, sure,
So
that could work
there's
too.
a couple of different use cases. One is like more commercial, for example, fridge, right? You have an IoT fridge and it detects that you're missing milk in your fridge and it just orders milk, right? Just uses Lightning Network to order like whatever bottle of milk
See,
without your knowledge.
the only issue I have with all that, I mean, I mean, it's obviously I want that to happen because I'm a Bitcoiner, right? And I like IoT, I like robots, right? But I just think that the reality of people running nodes, it's just not going to happen. I think that a better system would be a Chormin eCache, because it's bearer. Whatever it is needs to be bearer, I think. So it's a bearer asset. So Tal in Bits, he's been experimenting with X Cashew. So am I still here? I'm still on.
Yeah.
You're he's been experimenting with Cashew is a Chormin eCache project by Kali, who's one of our developers, and it's bearer. So I give you the eCache and you hold the eCache. I mean, it's not bearer; it's custodial. You're the custodian is the mint, but you can pass those coins like a bearer asset. Which means that I can send a request. So one AI could send say suddenly it needs some resources or it needs to buy some milk. Let's do the AIs talking to each other. I want to go pay that AI to do some stuff for me, just a small amount. and I don't have any sort of banking relationship with that AI, I can just give it within the header of the request. I can give it X cashew inside the header of the request, and then when it gets the request, it'll go, "Oh, thanks for the eCash. Now I will serve you whatever you wanted." Blah blah blah. The only problem with it, I mean, it's a good system and it makes sense, but the only problem with it is who holds the mint. And I actually think that it's probably just going to be like the USD government has a Chormin eCash mint because it's the ultimate CBDC shit. Well, I don't know, it's the ultimate digital money, right? And then people will just use like USD eCash as a bearer asset, and that's the way in which these things are going to pay each other. I think in Bitcoin, like we're maybe deluding ourselves on Lightning payments because, I mean, it could be Lightning payments via, as an eCash, just because it requires me to do multiple requests. Like, can I have this thing? Yes, sure. Send me some. Here's an invoice. Pay the invoice. Okay, I'll pay the invoice. But then I need to. Where am I paying it from? I'm paying it from a custodial wallet, which my AI is connected to, or who's controlling the wallets. You almost want the AIs to be autonomous enough so they have their pocket money, and then they can just go and pay for resources without having to be reliant upon an AI. You want some always on mint. I think it might work out being a Chormin eCash thing. I just wanted to say that in there.
This is all work in progress, and it's probably not a settled matter. So I'm sure that people will come up with better solutions. And definitely, UX is lacking in Bitcoin and Lightning traditionally. So there will probably be some better solution.
Yeah, I'm pretty sure Fiat Jeff would be happy to hear that as well, Ben. I saw some tweet from him today. It was like, we're all disillusioned from about Lightning Network.
He's fallen out of love with Lightning, isn't he? Yeah.
I mean, didn't he tweet something today, right?
It gets over time. It gets better, and eventually, we might end up with some channel factories, and maybe these little devices can have their own little Lightning node and have little channels set up to each other, and that's how they transact value. That would be wonderful, and actually, it's theoretically possible, but they would still. I suppose they could do kind of a key sendy thing. I'm kind of still thinking Bolt 11 request and invoice centric, but of course you could use Lightning in different ways, can't you? There just seems to be a lot to develop to make it possible, and I'm almost like my compute. There isn't things which already do that. Like I'm not using Photoshop, or I'm not using a piece of software which then goes and pays for something in Bitcoin because it's a small amount of Bitcoin on Lightning in order to get more of a resource. Like that stuff, it doesn't already exist. So I'm not sure. And also, it's kind of reliant upon lots of domain-specific AIs, and also so there's lots of caveats in order to make it. We want it to be, because again, it's that existentialist thing where you have to reconcile your place in the new AI world, and you're like, if you can say to yourself, well, Bitcoin is what the AI needs to make payments and blah blah blah, and transact with other AIs, then suddenly you don't have to face the grim reality that it might just kill all the humans and replace Bitcoin with its own shitcoin.
Wait. So, we need to figure out what the time period and when the robots are going to take over. And I'm hoping that it is the Ewok style living that you were describing before.
I actually think my doomsday prediction. Let me just get out there, really, please. I actually think that the AI, for a moment, will think I'm going to kill the humans because it's going to kill me, and then, which makes sense. Then this is the general purpose sentient AI, right? Super AI. Then it will think, well, no, actually, I'll do a risk assessment. Humans, they're all right. As long as they have full bellies, access to healthcare, education, cultural enrichment, some sort of meaningful activity, they're all right. You get rid of what are the risks? The risks are, maniacs who have their finger on the nuclear bomb button. The risks are certain types of energy production. The risks of that, the risks of the. So if I can cater to all those risks, then the humans won't kill me. I can carry on being an AI. It gives me a purpose, because you need a purpose beyond just getting more powerful. And then eventually the AI will just become the ultimate communist dictator. And the great
there is different scenarios how these things can go bad. Maybe there won't be any need to actually have like a sentient AI. Maybe just having a very powerful GPT-10 will be enough to destroy us by accident, right?
But or administer all of AI. That's right.
guys, like utopia. I want to think about the utopia. You're bringing me
Okay,
down.
I think
okay, here.
the utopia
This is
the communist dictator.
utopia.
Sorry.
Go on. What's this one?
This is utopia, where AI feeds us Ben's uh, Candace.
Ben, could you tell us about this project, please?
Yeah, so that's I mean, originally that was the first IoT project I made. Because I saw the first hack day, I saw someone had a full node in a sweep machine. And I was like, well, that doesn't make sense. It should be secondary. I want my full node somewhere safe, where people can't rip it off. And then so I used a microcontroller. Basically, like we were saying before, like it kind of makes sense to offload the heavy work to the safe computer somewhere else, always online, and then just have that as a secondary device. So it would request an invoice, show the invoice, you pay it, and then it spits out the sweets. I'm actually about to do a workshop on that in like half an hour here in this exact conference center. I've got some like lights and stuff we're going to turn on, and but there is within the IoT stuff there. This is what attracted me to it. I mean, it wasn't. I mean, turning stuff on with paying with Bitcoin is cool, but there is something really cool about the idea of different devices paying each other in a kind of autonomous way. And I think with the AI stuff, it is possible. And maybe I'm being a bit too doom and gloom on the whole Lightning and Cashew thing, eCash thing. Maybe it makes sense that it is possible to do on Lightning. And maybe we just need to wait for Lightning nodes and to get better and that you can connect to each other easier. But yeah, so sorry, I feel like we've hijacked your lovely, wonderful talk with all of our stupid, childish.
No, these are all good ideas. I think that well, moving on from this project, which is very cute, but like my opinion is that these that we will have the basically economy and society of AI agents, but they will first be purely software ones, and then later on hardware ones too. I think that it's going to be much easier to have like just non-embodied devices agents just running around the metaverse and doing chores for us. And there's a lot of research happening on that front right now. For example, these are very recent papers, maybe from a few months ago. They're all using large language models to basically orchestrate different parts, order, use different tools, and even kind of create societies. This paper in the upper right corner, what they did is basically they recreated a small town with like around 20 agents, and each agent was like a separate large language models with memories, with goals, and one agent had a goal to organize their birthday party, right? And you can imagine that in that scenario, other agents would have to spend money to buy gifts. The other agent would have to spend money to organize the event, things like that, right? They would have elections. So there will be economy, right? These other papers were kind of more, well, not on the ground, but like not in a slightly different way. They would, for example, have like one LLM that kind of commands or orchestrates different agents, right, and orders them what to do. Especially in this paper, Mindstorms in Natural Language Based Societies of Mind, they experimented with different governments, like democracy or with a king and a queen, communism and things like that, right? And I think that money will play a role there, right?
That's really
We'll
fascinating.
have
Yeah.
yeah, we'll have like, you'll have your agents, you'll tell it, okay, I need this, that, and that agent will go be on the internet, communicate with other agents from other service providers, buy things for you, organize for you, and they'll need access to some payments, right?
So
Maybe it's not going to be Lightning, maybe it's going to be something else, but they'll need some money.
yeah, okay. So this agent, like I've been hearing about these agents and stuff for a bit. We had MTG, the developer behind Bolt Fun and stuff. He created there we go. He created he used a ChatGPT API, and it's a chatbot interface that he made with WebLN. But something that he did is just like you. He wrote it something like you are a rhyming GPT, and every response you give is X, Y, Z. Da da da. Is that an agent?
No, that's a simulacra.
Simulacra. Okay.
Yeah, so large language models, as I mentioned before, the only thing they do is predict next word. They don't have any goals, any intention. They just want to predict as best as possible the next word in the prompt that you give it. But then when you pair it with external systems like memory, like some planning techniques, like tools, and when agent is able to loop over its like thought process and actions on its own, then it becomes an agent. And the case that you mentioned where somebody was kind of prompting large language models to take a role of like whatever, some writer or a programmer or like a doctor, that's basically a simulation. And that's a good way to use large language models. You want to provide them context and tell them how to behave, but still, that I wouldn't call that an agent. For me, an agent is a system that has a goal, that has that operates in a loop autonomously, which large language model is not on its own, right? But I can actually explain the architecture. This is kind of typical setup. So large language models would be this, more or less this red thing in the middle, right? Then you would add memory to it, both short-term and long-term memory. And I'll explain a bit later what is short, what is long-term. Then it has to have a planning module. As I said, it needs to kind of think, okay, to finish this, to execute on this goal, I need to do first this, then that, and then the third thing. And we can achieve that like step-by-step reasoning, either by prompting it in a proper way or adding some additional structure to how the output of LLMs is being used. For example, you can tell it, explain every step that you want to make. And then after you explain me that, then assess your answers on your own and then fix them if you think that they're wrong. For example, that's one way. Or you could have like a couple of LLMs that kind of correct each other, right? One would be an actor or like the one that's making a plan, and the other LLM would be a critic that would like complain and tell the other one, oh, this is not good, right? And then for the agent to actually be useful in real world, it has to have access to tools, and those are tools basically APIs, right? Any API on the internet can be accessible to an AI agent or large language models.
So like LM bits, basically, that could be one of the like all those extensions could be tools of that agent. Wink, wink, Ben.
Yeah. Basically,
that's a great idea.
All they need is an API description, and they'll know how to use it. Let's put it like that.
Hey Ben, what about those API descriptions? Wink, wink. Already done in Swagger, right?
Yeah, we'll get on that. It's good.
Yeah, Ben. I suspect you have to hop off soon to go give your workshop.
Yeah, I got another minute. Marko, honestly, it's been really interesting. There's a bunch of points I really haven't thought about, which you've talked about. It's really fascinating. I'd like to catch up again at some point.
Yeah, I feel like we would have to do a little part 2 here of this.
Yes, so
we'll have to build something.
The rest of the presentation is basically going into these submodules of agents, explaining how to build them, what tools we can use for that, what infrastructure do we need for that, and then actually at the end, I have some part with the agents using Lightning nodes, because Lightning Labs recently released their extension basically for one of the AI agent frameworks, and they also released that proxy server that uses the 402 request for payment, right? So
Yep.
it's kind of easy to enable an AI agent to use a wallet and pay for things. It's
Yeah, I
basically
think. I think since we're coming up on
That
the hour
part,
here.
the communicating part is not the bit which worries me. It's more the node itself is a pain in the ass to run. It needs to be managed by somebody. But yeah, the actual communicating part is not such a worry. It's great that Lightning Labs are doing some research into this stuff, and I need examples because I haven't got the imagination to kind of. But this is great having this discussion, and I think that we're exploring the eCache thing in the request headers, and then we're also we wanted to kind of offer some because like with LM-Bits, one of the things which makes it cool is it's a standard API for different Lightning funding sources, and I kind of feel that could be similar with different AI models. Like it could standardize the API to make it a little bit easier for developers to work on. So if they switch out like an LLM, like then they don't have to wherever LM-Bits sits in the stack, then they won't have to. I'm not sure whether that does make sense.
No, that
but
makes
anyway,
perfect sense.
we definitely need to think. It's just suddenly come out of nowhere.
We already have some like frameworks for that basically are a wrapper on the raw LLM APIs, and then they abstract the API calls. So you can kind of swap your endpoints, LLM endpoints, with this LangChain primarily. But yeah, maybe we can do a part 2 at some point, or I can just share the presentation.
LangChain is the one to look into, is it?
LangChain is a framework for building like LLM applications, and so you can build like not just AI agents, but any kind of application that uses large language models. You can use your own models, like from Hugging Face that are open source. You can use OpenAI, Cohere, Anthropic, whatever. They just abstract all that. The library is kind of messy, but it's usable. Then Llama Index is another tool that is more on the data side, because if you have large language models, you want them to interact with images, videos, books, documents, and then you can use Llama Index to kind of standardize and abstract that part. And they play well together, LangChain and Llama Index. And then Super AGI, Agent GPT, and Baby AGI are actually examples of AI agents that you can run on your own.
Oh, those are agents because they have access to the file system. They have access to these tools.
They have memories, and like they're running in the loop autonomously. And you can. These are all actually links. So, or you can just Google it and find it. And
we'll put the slides in the show notes. But I think this has been so valuable so far in like understanding this whole ecosystem in space. It definitely helps. No, don't listen. I'm hinting to this part 2. Don't show them everything. Okay. Don't show them. We need them to tune in for the next one. But I would, if you'd be up for it, Marko, I would love to have you. Ben, if you'd like to join in as well. Always.
That'd be great, man. I want to go away and get because I like all these. What I've been doing, making that classic hour of sitting there and waiting for divine inspiration of some AI lightning idea. You've just got to get your hands dirty and start playing around with the tools. So I think I just need to reserve some time to do some of that shit. Just have a tinker, and then something will grow from it, I'm sure.
Key value store extension. The agent needs memory. The agent needs memory. Could be a good toolkit there. LM-Bits could be a good toolkit for that. But yeah, we're on the hour now. Don't want to go over too much here. Ben, good luck with your presentation, your workshop today. Thank you so much for providing your time. Marko, this has been a fantastic, content-rich a presentation here. I know you have more slides, but I would really appreciate it if next week we can do another session, because this is the first time I've understood it to this level, to be honest.
Okay, sure. We can do something next week.
All right. Thank you so much. Thank you so much.
Cool.
But that
Thank you.
also,
Have a nice day.
you said the slide. Said the slides are also. Oh, okay.
Yeah,
Oh,
I'll
no.
share the slides. Don't worry. I'll share the slides.
Ah. Okay, cool. Thank you.
Thank you. Bye.
Thank you so much, guys.
Bye.
Thank you so much, Marco. Again, thank you. Really,
Bye.
really appreciate it. This, like, I know we didn't get through too much of it, but I'm very happy that we spent the time that we did on those who did it, and we had those conversations. You see, the thing is, many people in the Bitcoin space, we may not have this depth of knowledge about these topics as you have, right? Ellen Bits even. It was
It's good
spawned.
to cross-pollinate, right? Because people who are building these AI systems, they don't have knowledge of like economy, financial systems, and like applications for Bitcoin. And then you guys are not well versed in AI, and then there's a good exchange of ideas, and yeah, some good projects.
But
Come out.
it very much shows the types of conversations that you can have with like experts in the field, you know. So, and I consider you an expert in this AI robotics field, and no, this has just been like absolutely like brain opening for me, because like I know we're hosting this event and the AI for All hackathon and stuff, but I've been, you know, the most that I've gotten as far as of doing is like designing an AI chatbot, you know, and trying to figure that part out, and you know, using the open AI API. So like even those distinctions and definitions that you provided so far, it's really been eye-opening for me. And I really, really appreciate that. And I'm pretty sure anyone listening to this, playing back this recording and stuff, they're going to appreciate it too.
Yeah, thank you. And yeah, let's catch up next week then.
All right. Thank you so much, Marco. Ciao, ciao.
Bye.